This is the walkthrough video for PCTC 2022, round 2, question 10, then digit search tree. So I actually think this is probably the hardest question. It's not in the sense that it's like the hardest one to write code for, right? Because whilst these two questions were algorithmically difficult, question 10 is just difficult to implement, especially in Python, and especially if you don't want to do object-oriented programming, which I don't want to do. So I'm going to show you my solution, and it's probably not the solution that's going to make your teachers happy, but I think it makes the most sense, I think. Okay, so what we're going to do is we're going to represent our tree as a dictionary, almost as if it's a graph. So first off, let's just take in our two inputs. So let's say nums is our first input, and we'll keep it as a string so we can iterate through it. And our next input can be row. Let's turn that into an integer. Okay, and now let's create our tree. So our tree is just going to be an empty dictionary. But of course, we should probably just add the first, like the top of the tree. And the top of the tree is going to be the 3. So the top of the tree is going to be essentially whatever our first inputted number is. So let's just actually call that variable top. And top is going to be equal to num0. And so in this case, in this example, the top is going to be equal to the string or the digit 3. And now let's actually just add that to our tree. So tree can be top, and it can start. So our tree can start off like that. And what this essentially means is that we're going to say that the key in our dictionary is going to be whatever the node is, and the value of that key is going to be a list that contains 2 elements. The first element is going to be the node on the left, or the child node on the left, and the second element is going to be the child node on the right. But as this is the start of the code and we don't have any elements underneath top yet, we're just going to say -1. So -1 is going to be our placeholder for if there's nothing there. For example, the list under 4 for the finished tree would be -1 and 7, because there's nothing here, so we're just going to say it's -1. And then obviously there's a 7 there, so we're going to say that's 7. So this is now our starting tree. We've taken our inputs and we've created our starting tree. Now we can go ahead and start coding. So let's go through every number in nums, obviously except from the first one, because we've already dealt with the first one and put that here. So we're going to say find range 1 to 10 as opposed to 0 to 10. And just to point out, there are always going to be 10 numbers from 0 in our input. So now what we're going to do, let's extract that number. So let's say num is going to be equal to nums I. And let's also say we need to keep track of the current. So what we're going to do here is we're going to effectively go down the tree. So if we have a tree, say we have this tree to begin with, or at some point in our code we have this tree, and we're going to, and so the next number here is going to be 2. And so we're going to go down this tree until we find somewhere to place 2. And so we're going to be like, okay, the top of the tree is going to be 3. Is 2 smaller than or bigger than 3? It's smaller than, so it's going to go to the left. And so we then look at 1, which is on the left of 3. And we're like, okay, is 2 bigger than or smaller than 1? It's bigger than 1. And there's no nodes. We're just going to put a 2 to the right of 1. And so we'll end up with this tree that I'm circling now. So we'll have the 2 in place. And so that's what we're going to do. We're just going to build up our tree from top to bottom for every number we get. So we obviously need to keep track of the starting number, or I guess just a current number. So let's say the current number is going to be equal to, at first it's going to be equal to the top number, right? Because as I've shown in the process I've just like kind of gone through, we always start at the number at the top, which in this case is a 3, but that's stored in our variable top. And now let's have an infinite while loop. And this while loop will run an infinite amount of times until we find where we can put our current number, and then we can break out of it. Okay, so we're going to say if our number is bigger than our current number, then what we want to do, we want to look to the right of our current number. And so let's do that. So let's say our new number is going to be, or I guess our new current is going to be our tree current 1. But of course, if this is like a -1, then that means there isn't a node there, right? Because a -1 is our placeholder. It means that there's nothing there. So we also need to check for that case. So if new current is actually just equal to -1, then there's nothing there, and therefore we can add whatever our num is to this position. So if it's a 1, then we can be like tree current 1 can be equal to num, and we also need to add our what is it? We need to add num to the dictionary or the tree. So that's going to be tree num, and that's just going to be our placeholder empty list, or I guess our -1 list. So what we've just done with that code is we've looked, for example, where the two should go, and then we've added the 2, and then we've said there's nothing underneath the 2, right? The 2 has no children nodes or child nodes, and to indicate that we just say -1 -1. So what we've done is we've effectively modified the child nodes of tree current, and then we've also added empty child nodes for the current number. Now this is basically it, I think. So we can just copy that. We can copy that, but for the case where num is smaller than current, so let's just put that in else. And if num is smaller than current, we're always dealing with the left child node. So we're always dealing with index 0 as opposed to index 1. So let's just change these two numbers to 0 as opposed to 1. And at this point, we should pretty much have our entire tree built. So, oh yeah, we also need to break, of course. Yep, so after we found a place for our number to go, we can break. But if we haven't found a place for a number to go, then we need to repeat the while loop with a new current. So our current is going to be equal, should be inside the while loop. So our current is going to be equal to new current. And so we're just updating our current number that we're checking as we go through this while loop. And as soon as we find a valid place to put our num, then we break out of it. And so if I were to print tree, and let's, for example, take in this input and just run the test case here, then in theory, we should hopefully see this entire tree encoded as our dictionary. And so what this says, it says 3 has child nodes 1 and 4 in that order. Yep, 1 and 4. Then it says 1 has child nodes 0 and 2. Yep. 4 has child nodes nothing and 7. Do we see that? Yep. 7 has child nodes 5 and 8. Yep. And then these two are mostly just empty. Yeah, the rest are mostly just empty. Yep, so that looks right. And of course, one thing you may notice is all of these are actually still strings. Like, we haven't dealt with integers in our program yet. And that's fine. Like, you can actually compare a string with another string. So, like, for example, the string 8 is actually bigger than the string 6. So that's a good tip to have if you just want to save yourself writing a few lines of code and dealing with integers and strings. Okay, so we've got our tree entirely built up. Now the question is, how on earth do we get the right row of the tree? So in this case, how do we get the 4th row of the tree? And this is quite difficult. So you can either kind of just, like, for example, do a breadth first search or a depth first search to try and go through the entire tree to figure out which numbers are on a given row, because you can just check how deep you've gone into the tree. Or as you build up the tree, you can check whether the number you're about to add is going to be on the row of interest. And if it is, then you can just print that off or add that to your answer. And so that's the method we're going to do, because it's way easier than having to code a whole extra graph algorithm like a BFS or a DFS. So to do that, we need to keep track of our answer. So let's have an answer list. And every time we add something to the tree, that means that's an opportunity for us to check whether this number that we just added is on the row of interest. And so how do we do that? We need to keep track of the current row as well. So current row is going to start off at, let's call it row current. So row current is going to start off at 1, because the question starts counting from 1 as opposed to 0. It's like, this is row 1, this is row 2, this is row 3, this is row 4, this is row 5. So it's going to start off at row 1, yeah. And every time we repeat the loop, we're going to increase row currents by 1 because we're moving up the next, or I guess down the next row. Okay, so now for our actual check. So we're going to say if our current row, so row current, is equal to the row of interest, which if you remember at the start, is just called row. That's what the user inputted, or the checker inputted. So if we're on the relevant row, then let's add our number to our answer list. So again, just to reiterate, what this will do is it will check to see whether we're about to add something to the row of interest. And if we are about to add it to the row of interest in the tree, then let's also add it to our answer. But you may notice a slight problem, which is that when we add a number to a tree, we're adding it to the row below the row we're currently on, right? So if, for example, we're checking row 1, let's say we're here, we're checking row 1, and we add a 2. We're actually adding the 2 below row 1. Sorry, this is row 2, isn't it? Yeah. So this is row 1, this is row 2. And let's say we're checking 1, and we want to add the number 2 to our tree. The number 2 is going to be added to row 3 of our tree, even though we're only checking row 2 right now. And so we need to make sure to check that if row current plus 1 is equal to the row of interest, because this is the row we're actually adding our number to. So if that row is equal to the row of interest, then we can add it to our answer. And let's just copy paste the exact same thing down here. And now I guess the final bit of the code would be to print out the row. So we should be able to print out just like that. So we're using the asterisk to unpack the answer list, and that just effectively, instead of printing out a list, it prints out every element in the list with a space in between. So it just prints it out in the correct format, essentially. Like we can very well just print out the answer, but it's going to complain. Well, it's not going to. Well, yeah, the check is going to complain, even though, see, our answer outputs are correct. It's 5 and 8, but it's not the same format that we want. So we need to change that. And actually, there might be a slight issue with this, which is there a way to demonstrate this? Yes, there should be a way. So let's say I wanted to get row 3. What am I expecting? I'm expecting 0, 2, and 7. And what does it output? It outputs 7, 2, and 0. So it's got the correct numbers, but it's got them in the wrong order. And how do you fix the order? Well, that all of a sudden seems like a way more difficult problem. But actually, you may notice that it's always going to be increasing. Because our tree, by nature of how the tree is defined, everything on the left is the smaller one, everything on the right is the bigger one, right? So our row should be 0, 2, and 7, which is in ascending order. Same for this row, it's 5 and 8, that's ascending order. 6 and 9, that's ascending order. 1 and 4, that's ascending order. So each row, reading from left to right, is in ascending order. And so all we can actually do is let's just print out the sorted list of answer. And of course, we should also turn that into the correct format by just unpacking with adding the asterisks there. Yeah, and so if we submit that code, we should now hopefully get all 10 points. Oh, we get 9. Okay. Okay. So that's probably because, yeah. So if we try to, for example, output row 1, what we're expecting to be output is a 3, right? Because that's the only thing on the first row. But what's actually output is nothing, I believe. Yeah, nothing. Because we only start checking for the rows from row 2 onwards, because we've already added the 3. Like we add the 3 up here on line 5 before any of our loops begun. And so we should probably check for that too. So just right at the end of our code, let's say if the row of interest is actually row 1, then let's actually just print out top, which is the very first number. And if it isn't, then of course we can print out whatever we had below. Too many requests. Oh no, that seems to be working. And I assume that's what the test case was, yeah. And so that should give us 10 out of 10. Yeah, that was a tough one there. So feel free to take the code, play around with it, print stuff off, and figure out how it works.